So this is addition and subtraction. We had done this just a while back. Very simple concept. Whatever operation you do to the dividends, the same operation you do to the divisors. The same operation you do to the remainders. That's all. Okay. So for example, if n is equal to 30 into 4 plus 15 minus 8. Okay. And this is getting divided by 7 and we want to find the remainder. Okay, so first method, obviously I've taken a very small number, but we will take bigger numbers. But this is just to explain to you. 13 to 4 plus 15 minus 8 is equal to 127. So one method is obviously you divide 127 directly by 7 and you get a remainder of 1. But I want to show you the addition, subtraction, multiplication part. The only thing you can't do here is division of dividends. Rest, addition, subtraction, multiplication is fine. So instead, if we solve each part separately, so I divide 30 by 7. 30 by 7, I get a remainder of 2. I divide 4 by 7, I get a remainder of 4. I divide 15 by 7, I get a remainder of 1. And I divide 8 by 7, I get a remainder of 1. Okay, so instead of these numbers, I replace them with their remainders. And remember, this is a very important part. In division, if you are concerned only with finding the remainder, anytime you can replace the dividend with the remainder. Okay, mark these words. Anytime you can replace the dividend with the remainders. Okay, and carry on. So if we replace them, 30 will get replaced by 2 and the signs will remain. Multiply will remain multiply. 4 will get replaced by 4 because the remainder is same. 15 will get replaced with 1. 8 will get replaced with 1. All the signs will remain. So net you will get 8. And as 8 is bigger than the divisor, it will get divided once again by 7 and you will get a final remainder of 1, which is same that we had got earlier. Okay. And I also want to explain this using negative remainders. So let's understand that also. So 30 divided by 7, I can say that my remainder is 2 or I can say my remainder is minus 5. Same thing. Similarly, 4 divided by 7, I can say my remainder is minus 3 because it is 3 less than 7. 15 divided by 7, I can say my remainder is minus 6. And 8 divided by 7, I can say here also my remainder is minus 6. Okay. So now if we replace minus 5 into minus 3 plus minus 6 minus minus 6, you get 15 minus 6 plus 6, which is 15. Okay, 15 you divide by 7 once again to get a final remainder of 1. So as you can see, you can take positive remainders, you can take negative remainders, whatever you want you can take. You just keep the same arithmetic operators as was with the dividends and you'll get the same answer. Okay, let's apply this. Let's say I have this number. One we had applied earlier also. Here also you can see 123 by 9. So I have basically 123 into 124 into 125 by 9. Okay, so multiplying all of them and then dividing by 9 and finding the remainder is a longish method. What I'll do is I will divide them individually and I will look at remainder of 123 by 9. I'll keep the operator same into remainder of 124 by 9 into remainder of 125 by 9, which will be easier for me. So 123, 90 will get divided how many times? So 9 will be 90 plus 27. You will have 117. Okay, 117. So the remainder here is 6. Okay, then 7 and then 8. 6, 7, 8. That is what is my remainder. Okay, so 7 into 6 is 42. 42 into 8 for 320, 336. You get 336 and 336 I can again divide by 9 and you'll have how much? 27. So you'll have 66, 63. You'll have remainder of 3. Okay, even here you may say that even this number 336 is large. And instead of taking positive remainders, why not take negative remainders? Which again is an excellent thing to do, because when the remainders are close to the divisor, it will make sense actually to take negative remainders. So instead of 6, I can say my remainder is minus 3 into minus 2 into minus 1. That's also fine. 8 basically is nothing but -1, 7 is -2, and 6 is -3 because your divisor is 9. So net your remainder is -6. And when your remainder is -6, to convert it to positive, you add the divisor, -6 plus 9, you get 3. So one is this solution and one is this solution. I'm sure you'll find the negative remainders as a shorter and faster and lesser calculation oriented solution. And you can see both of them will give you the same thing. What you should definitely not do is multiply these three numbers. That is a complete wastage of time. Okay, fine. Let's look at this question. What is the remainder when 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial up to 100 factorial is divided by 5? How can we not have a factorial based question here? We have done factorial almost in every concept. Okay. Now, if you see, this actually is not a complicated question. I hope you have understood that, because 5 factorial onwards will be multiple of 5 and they will get divided by 5 fully. They will not give you any remainder, right? Because 5 factorial is 5 into 4 into 3 into 2 into 1. And when you divide this by 5, your remainder obviously is going to be 0, right? 6 factorial will also have a 5, 7 factorial will also have 5. In fact, everything from 5 factorial up to 100 factorial will be multiple of 5, and they all will give you a remainder of 0 when they are divided with 5. So your question basically boils down to just this much. This divided by 4. Sorry, this divided by 5. Okay. And now here you can either do it together or you can do it separately. Not much calculation. 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, and 4 factorial is 24. So this divided by 5, 24 plus 6 is 30, of 33 divided by 5, your remainder is going to be 3. That is the answer for this question. So while it may look like a complicated question, in a sense, this is a very simple question. You only have to calculate till 4 factorial and you will get a remainder of 3. Okay, great. Let's move on. Now this is a very important concept, and again nothing new, you already know this, but I wanted to just do a recap. A to the power n minus b to the power n is always divisible by a minus b. Okay, for example, when you have a square minus b square, it is equal to a minus b into a plus b. So you can see that you have a minus b there when n is even. And when n is odd, a cube minus b cube, then also you have a minus b. So a to the power n minus b to the power n is always divisible by a minus b, irrespective of n is even or n is odd. Okay, remember, very, very important. And a to the power n minus b to the power n is divisible by a plus b if n is even. Now for plus there is a rule. For a minus b there is no rule. A minus b, this is always. Okay, but a to the power n minus b to the power n is divisible by a plus b if n is even. You can see here. Here it is divisible by a plus b when n is even. Similarly, if it was a to the power 4 minus b to the power 4, this will convert to a square minus b square into a square plus b square. And a square minus b square will convert into a minus b into a plus b into a square plus b square. So this will also be divisible by a plus b. So a to the power n minus b to the power n is divisible by a minus b always, but a plus b only if n is even. Okay. Also, a to the power n plus b to the power n is divisible by a plus b if n is odd. Okay. So a plus b obviously is divisible by a plus b. And if you have a plus b, a cube plus b cube, I hope you remember the expansion for that. Expansion is a plus b into a square minus ab plus b square. So here also you can see that you have a plus b. So a to the power n plus b to the power n, plus we are taking for the first time, this is divisible by a plus b only when n is odd. And if you ever have a confusion or you don't remember in the exam, all that you have to do is take n as 1 or n as 2 and cross check. So if I take n as 1, a minus b, a plus b. So obviously this is divisible by a minus b. This is divisible by a plus b. If I take n as 2, a square minus b square, you can see that this is divisible by a minus b. This is also divisible by a plus b. Okay, a square plus b square, this is not divisible by anything. Okay, so what does this tell you? That n is odd here, n is even here. In both the cases, a minus b is always there. So anything of the form a to the power n minus b to the power n is always divisible by a minus b, which is the first rule. Then when n is even, you can see here, this is divisible by a plus b. A to the power n minus b to the power n. You can see here you have a plus b. Okay, so it is divisible by a to the power n minus b to the power n is divisible by a plus b. And when you have a to the power n plus b to the power n, then it happens when n is odd, then it is divisible by a plus b. So you can put 1 or 2 as values and check and just recollect the rule in case you don't remember that at that spot. Okay, so let's look at a couple of questions on this concept, and these questions have appeared in CAT in various formats also. So I have 7 to the power 6n minus 6 to the power 6n, where n is an integer greater than 0, is not divisible by. So what all is this divisible by? Okay, so this can be written as, what all can we write this? This can be 7 square to the power 3n minus 6 square to the power 3n. Okay, or yeah, so basically this is a to the power 3n minus b to the power 3n. Okay, now depending on the value of n, this can be even or this can be odd, but you know that a to the power n minus b to the power n will always be divisible by a minus b. Okay, so this is a, this is b. So a minus b is 7 square, which is 49, minus 36, which is 13. So it is always divisible by 13. That is for sure. Okay. Whether it will be divisible by a plus b or not, I don't know. A minus b, though you know, is always correct. A plus b, what was the rule? When n is even, it is divisible by a plus b only when n is even, right? A plus b when n is even. And whether my n is even or not, I'm not sure here, so I can't say that. Okay, but let's check another version. Can I write this as 7 to the power 3 to the power 2n minus 6 to the power 3 to the power 2n? Yes. So this is of the type a to the power 2n minus b to the power 2n. This is always even. The power is always even. So this is very similar to a square minus b square. So a square minus b square, you know, will be divisible by a minus b also, and it will be divisible by a plus b also. Right? Okay. So 7 to the power 3 is how much? 343 minus 216. That will give you 127. So it is divisible by 127 also. And it is divisible by a plus b, which is this plus this, which will give you how much? 559. So it is divisible by 559 also. Okay. So what is it not divisible by? It is not divisible by 81. So that is the answer for this question. Okay, using simple concept of a to the power n minus b to the power n. Okay, let's do one more similar question on this. What is the remainder when 14 cube plus 15 cube plus 16 cube plus 17 cube is divided by 62? Okay, so I'm dividing here by 62. So what can I do here? This is cube. Cube, I hope you remember. So a cube plus b cube is divisible by what? If you remember, a cube plus b cube is equal to a plus b into a square minus ab plus b square. Is this what we wrote? Let's check here. Yes, right? So that is what is the expansion. Okay. Now first thing, if you see, this is even, odd, even, odd. So when you add them, you'll have 2 even and 2 odd, which means the sum is going to be even, which means it is a multiple of 2. So it is divisible by 2, that's for sure. Okay, fine. Then I have to check divisibility by 62. 62 is basically 2 into 31. 2 I already know it is divisible because the sum is going to be even. So basically I have to check for 31. And if you see carefully, 14 plus 17 is 31. 15 plus 16 is also 31. So I should group them. So I should have 14 cube plus 17 cube. This will be divisible by 14 plus 17. Okay. And something else. Similarly, 15 cube plus 16 cube will be divisible by 15 plus 16 into something else. 14 plus 17 is nothing but 31. 15 plus 16 also is nothing but 31. So both of them will be divisible by 31. Hence, the number is going to be divisible by 31 and also by 2 because it's an even number. So it will be divisible by 62. There will be no remainder. So answer would be 0. Okay, so these kind of questions also come where the concept is very, very basic and elementary. All that you are being tested is on your knowledge of a cube plus b cube. Okay, and these questions can be answered so easily. Okay, then binomial theorem. I referred to it earlier. So binomial theorem also becomes very handy at a lot of times. All that you have to remember is a plus b to the power n is equal to summation. N goes from r is equal to 0, so equal to n, NCR a to the power n minus r br. Okay, where r is between 0 to n. R starts from 0, goes till n. So the expansion of this is this. What is important in this expansion is that b is not present in the first term and a is not present in the last term. Okay, so when a plus b to the power n, or it can be a can be a multiple also. So ma plus b to the power n is divided by a. So a plus b to the power n is divided by a. Then your last term, which is b to the power n, that will be the remainder. Or even it can be ma, some multiple of a, plus b to the power n. This also if you divide, then also the remainder is going to be your last term, which is b to the power n. So this is a binomial theorem which is used at so many different places. It is useful for remainder also. Okay, for example, let's look at this question. The remainder when 45 to the power 23 plus 50 to the power 23 is divided by 19. Okay, so I have 45 to the power 23 plus 50 to the power 23. I'll divide them separately and then I'll just add the remainders. So first one, you can see that 45 can be written as what? Can I write it as 19? Multiple of 19 is 38. So I'll write it as 38 plus 7 to the power 23 divided by 19. Okay, now 38 is nothing but 2 into 19 plus 7 to the power 23 divided by 19. So this is same as what we discussed just now, ma plus b to the power n divided by a. This will give me remainder of b to the power n. So here my remainder will be 7 to the power 23. Of course, it can be simplified further, but let's leave it at this. Similarly, the second part, 50. Now your 19 ka third multiple is 57. So I can write this as 57 minus 7 to the power 23 upon 19, which is same as 3 into 19 minus 7 to the power 23 upon 19. Same this format, right? MA, instead of plus you have minus, so B obviously can be minus, not a problem. Okay, so this is going to give me a remainder of minus 7 to the power 23. Okay, so now you can see remainder is 7 to the power 23, remainder is minus 7 to the power 23, and because the power is odd, minus sign will remain. So net both the remainders will get cancelled out and your final remainder is going to be 0. Okay, so very simple application of the binomial theorem, and you can see how such a complex question can be solved so easily. Okay, all that you have to figure out was 45 is 38 plus 7 and 50 is 57 minus 7. So using the concept of binomial theorem, we are also using the concept of negative remainders. And my both remainders get cancelled out and I have my answer straight.